The next talk is one that I personally eagerly awaited. Laurentiu Matei, Business Intelligence Director at EMAG, will share how they implemented for Fashion Days the Black Friday Proof of Concept real-time dashboard. We will also discover the open source technologies they used and the business benefits of having actionable real-time data.
Hello, thank you very much for inviting me to this conference. I'm sorry we cannot meet in person, but hey, I'm living in Microsoft Teams now, so the conferences are here too. So what I want to do, I will show an example today of a little something that is working for us, but because I don't have enough screen space to show you the entire EMAG architecture, maybe we can do that when we meet at a real live conference. But this is an approach that you can use in your day-to-day operations. My challenge is always to look for something that can be applied for other companies too, not only for EMAG. So I will start off with something I've been practicing, sharing my PowerPoint. And hopefully you can see my presentation.
Yes, we can see it. It's perfect.
Thank you very much. Okay, so what we will be talking about today, a short introduction of who I am, some random advice that I added this morning to my presentation, because why not? I can always try to take the presentation in the last moment. We'll talk about some priorities when we talk about data. We'll talk about how real-time is real-time, because our subject is real-time. And of course, the Fashion Days real-time dashboard, what I promised you, the data flows, the technologies, and the baby steps approach that we took for it. And some approximation in joining real-time data with no so real-time data. And last but not least, some costs of this, because people keep asking what's the cost of starting using big data and how much would it take to implement. It's interesting because we did this in a team that had no prior experience with real-time dashboards and technologies that were used. And some work in progress, something that we're working on for this year based on big data. Hopefully I'll have time for that. So a few things about me. I am the BI and the ARP director at EMAG since February this year. I've been working in software development until then, and this is actually my first presentation regarding data, and I'm a bit nervous about that, but I'm sure it will be fine. I started my new role with a completely new team in February. I moved to my new office, and as a random fact, in a few weeks the office closed and we all moved home, and I only interacted with my team virtually since then. That's been quite a challenge. I graduated the Faculty of Automatic Control in Bucharest in 2003. I also graduated the Alexandru Ghica High School in Alexandria in 1998, and I'm always proud to say I grew up in Alexandria. Maybe people changed their mind about my hometown. I developed software for various industries until this spring. I joined EMAG in 2011 as a software developer. Then I started leading people in 2013. Yeah, and I moved to the current position of BI and ERP director this spring. It's interesting because as a software developer, I've been mostly interested in creating microservices and tons of disparate data, and now my job is to bring it all back together. Now for the slide that I added today to break the presentation, some random advice. Things work until they don't work anymore. So this is more serious than it seems, because everybody say they have lots of data, but the thing is, lots of data means different things to different people. So I think we should all constantly wonder when our big data becomes too big data, and we need to keep looking at the future. This is coming from my experience at EMAG, because things always grew, and what we thought 2 years ago will be too big is now business as usual. So for the purpose of this slide, big data is data that you can handle, and too big data is data that you cannot handle anymore. And this happens, I think, with any technology that you are using, and you need to be really aware of the limits of the technology that you are using. Now for some priorities, we always talk about big data and real-time data, and that's really cool, but very often we forget the basics. So we should clarify what our priorities are before discussing real-time data. And the first priority should be having the data, and that's most often not taken into account. I've seen so many projects launching and saving their data in some database that is not accessible for anyone else, that I cannot count. So this is the first important thing. You need to have the data available. The second thing is to have trustworthy data. You need to know that the data is correct. You need to know that the data doesn't have gaps in it. You need to know that your data is correct. Also, you need actionable data. Everybody gets hundreds of gigabytes and terabytes and petabytes of data, but what are you doing with it? It's very important to select those indicators that tell you what you can do to improve things, and this is actionable data. And only after you get those things clarified, you need to look into real-time data, and I will cover later what real-time data really helps you with. Truth is, most of the time you don't really need it to be real-time. So now comes the question, how real-time is real-time? Because when asking different people what real-time is, they will give you different answers. So some people think 30 minutes qualifies as real-time. Some people think 1 minute. Some people think 1 second or 1 millisecond. You need to ask just before you spend lots of money to implement real-time, because this is really expensive, and you need hardware, you need software, you need all kinds of pipelines, you need monitoring before implementing real-time. And you may often find yourself in the situation where people did not need that kind of real-time data. And I did ask a question a few weeks or days ago, and I asked someone asking me for some real-time data, and I said, what do you mean by real-time? And they said me, we need really to be as close to real-time as possible, something around 30 minutes. So it's very important to ask the people for numbers and not settle for real-time or big or too much or things like that. Ask for numbers. Introducing now the Fashion Days real-time dashboard. We built this for Black Friday past year. Black Friday in EMAG group is I don't know how to put this. It's the most important event of the year, and it's a challenge for every system to be able to cope with the data that we get. So we got this dashboard built for Black Friday, and then we used it in business usual every campaign, and more recently every day after that. Now, I expect the question coming, why do we have that for Fashion Days and not for EMAG? Now, Fashion Days, to clarify, that is part of EMAG group, and Fashion Days is using the EMAG BI department to get their data. So we're colleagues, it's just a different brand. We already had something still working for EMAG. Speaking of things that are working until they're not working anymore. Past year, we still have dashboards that were working. They were close to real time, not quite real time, but they were doing their job. We didn't have this kind of dashboard for Fashion Days, and Fashion Days needed the data in Black Friday. In Black Friday, things change very fast, and you need to know what sells and what sells, yes, and what doesn't sell. So dashboards are really important, and commercial people are always watching them. Also, we use this as a proof of concept for new technologies without breaking things. It's really hard to, when you have something that is already working in Black Friday and people are used to it, to bring something completely new. So we take this baby steps approach. If we have something that we can implement for a brand or for a country or for a specific showroom, we try to do that and implement a proof of concept, proof that it's working there, and then iterate on that thing. Now that we are confident and we've seen these technologies working, we will increase the usage of these technologies. I will show you how things are working and what the technologies that I'm talking about are. What happens is that we get data from various sources. I mentioned lots of services, microservices or macroservices, because they are all kinds of sizes. And this is a simplified picture of them. So we have some applications with MySQL databases where we get orders from. We also have a data warehouse on Microsoft SQL where we get stock product information, and I will get back to that a bit later. We also get customers information from other services. We get that information with stream sets. We put it into Kafka for real time, and then we use Spark structured streaming for processing that information and then writing it to Kudu in order to be able to make queries over it. Then from the dashboard doesn't say here, the dashboard is written in Angular, queries through Impala, the Kudu backend. Now we also have some batch processes, because what happens in real time, you may lose some information, or some information may change in other systems that you are not watching. So we also have some batch processing, bringing us some information that we didn't get in real time. The technologies that we used for this are stream sets for ingestion. We used Kafka as a buffering layer. We use Spark streaming for data modeling. Kudu for storage, as I was saying, and Angular for visualization. We actually went on and built our own dashboard framework. Now, for some numbers about this, this dashboard is calculating in real time some 200 KPIs, and it has about a 2 seconds delay. I'm always asking how real time is real time, and this is what we get here, 2 seconds. We are processing 150 events per second now, and what we want to do before we can even try to get this to the EMAG brand, we need to go to around 2000 events per second. This is how the dashboard actually looks like. We are analyzing the top 30 brands that are selling today, and we have indicators for each of them. We're looking at order value, the number of orders, average selling price, gross margin and gross profit, and the quantity solved. And also at the left side, we have some aggregated KPIs like number of orders and customers and order value and order quantity. What we're doing, we are comparing these indicators with commercial targets and also with past data. We are looking at the same day from the past year. So what we have here is actually the most sold products from categories, actually from Hungary, from this morning. We have, regarding real-time data here, a fun fact. When we made all the indicators change in real time, people couldn't read it anymore. So what we actually had to do was to introduce a delay to give people the chance to read the indicator. So we need to be aware that when people say real time is not real time that they need. One other important aspect here is that we had to use some approximation, because what happens is that not all our sources are real time. And one example here is cost of goods sold and gross profit. In order to calculate that, we need to have the sales. The sales is the quantity. The sales are the orders that are invoiced, and invoicing happens a lot later in the process. This dashboard is made on orders. So when we have an order, we don't actually have the real-time stock and the real-time cost of stock. So what we are doing, we are getting that information from the data warehouse, and it has even a few hours delay sometimes. And what we do is use that data. We know it is not real time, and then look historically to see how much it differs from the real-time data. And what we realized is that the information that we show real-time is a good enough approximation, meaning it has a 2 percentage points error rate, so it can be either 2% higher or 2% lower. And the people looking at the dashboard know that, and they're perfectly okay with it. But it's important to say that you are using an approximation, and sometimes it's easier to use an acceptable approximation than to implement a whole system that calculates something in real time when you can live just as well with some approximations. Now, regarding the costs of this project, it took us 140 man-days to learn the technologies that I mentioned earlier and to implement. We had to learn how to ingest the data in real time, how to use Kafka and stream sets and all the technologies there. We had some idea on Angular though. What we're using is really small. We have hardware-wise, we have 4 executors with 4 CPUs, each of them with 30 gigabytes of RAM, and I have a typo here. And also virtual machines with 8 CPUs and 8 gigabytes of RAM for the Angular display. We still keep most of our data on premises because we have so many flows that are still moving data from side to side, and that would be really expensive if we put it in the cloud. So these are some machines that we have in our infrastructure. Now, who are our users? They are the commercial analysts that are working for Fashion Days, and what they get with the real-time data is they can do real-time adjustments, especially in a campaign where they have some bigger targets and they need to sell more than in a usual day. They can take all kinds of actions if they see real-time data, and they couldn't be taking those actions if they were seeing data like a few hours later. So some of the things that may decide is to invest more in marketing, maybe bring more traffic to the website, or slow down marketing if we risk to overload the warehouse. And we can also test different scenarios to see in real time which products sell better. And also one important thing, we have some estimations that we send to logistics every day, so they know how many people to bring in the warehouse, so they know how many trucks to call to the warehouse from the couriers. And having real-time data allows us to re-estimate those numbers and still adjust before the working days end, so that we can still deliver orders the second day as we always promise. And now for our next challenge this year is to process the eMAG real-time traffic. And we are close to the point where it's not working anymore. We have this issue where if we fall behind processing traffic, you get a wrong conversion rate. So you get orders in real time and you get traffic in not so real time. You get some indicators that are not real anymore. We had some tools that we've been using and that used to work in real time on lower volumes. And when I mean lower volumes, I say lower volumes than what we have now. By many standards, they are still big data. These things are not so real time anymore. So now that we see this, we need to make sure we implement something that we tried in the past years and it worked. So the current setup for ingesting the traffic is to get it with FileBit from the logs from the website. We do some processing in PHP, write it into MySQL, and then ingest it in ClickView. And there are several problems with this, especially with MySQL, which just cannot deal with writing all the data anymore. And trust me, the hardware MySQL runs on is a rocket, how we say it. And what we're doing now, we're still doing the file bit or the vector dev. I'm being told today, we're still doing some processing in PHP, but then using a more big data pipeline, writing to Kafka and then reading it and writing to Kudu, and then reading from Kudu with either ClickView, because we still have lots of code there, or ClickSense, depending on what we want to do with it. And we can also write it in HDFS, where anyone can play with it. But I will be talking more on that next time. So I think that's all from me. If there are any questions, I'll be glad to take them.
Perfect, you are right on time. We have some questions. I'm checking immediately because we have Konstantinos who had also some technical questions, but he's asking now if is the real-time data actually necessary for the task you described, because the systems you described seem to have a very large inertia.
I said, I don't know at what point during my presentation was the question asked. Some of the data is real time, some of the data is, yes, affected by that inertia and is approximated, and it's good enough for that, for us. We do have, for example, the real time stock data, but it would be a really high cost to bring it into this dashboard, so we decided where it's good enough for our usage. And another thing is we have systems in place for many years, and some of them are really doing real-time payloads only by using some not so real-time tools and not so big data tools, but putting lots of hardware on it. So that's always an option.
But what kind of businesses you think that they really need real-time data?
Well, it depends on how fast you need to action. I think the only things that really need real-time data are, I don't know, self-driving cars or airplanes or things like that. Otherwise, I told you we needed to put a delay so that people can read the data. So when you have people looking at the dashboard, they don't need so real-time data. When you have machines acting on that real-time data, that's when you really need it.
Claudio wants to know what were the biggest challenges in terms of performance to achieve that 2 seconds real-time data?
The greatest challenges were in the area where some of the people realized where we don't use real-time tools and big data tools, and that's mostly at the reading from the source MySQL, because we don't read from the production database, we read from what we call the reporting slave. And what happened is that it was more likely to get a delay at the MySQL slave than at the rest of the pipeline. So yeah, that's something that we look into for now.
Okay, and you had a nice intro and you said something like things work until they don't work anymore.
Yeah.
So when talking about big data, when you should realize that that moment it's coming, and what it's exactly that you should do to prepare?
This is exactly what you should be doing. You should be testing on smaller data sets from your company and just stress those things, because it's hard to see when such a thing is coming. It happened to EMAG this spring when everybody moved home and they started ordering online, and you realize we had a spike that we did not expect in any way. But the only way to be prepared for that is always have tests and wonder what if. What if tomorrow we get 10 times the traffic? Will we be able to do it or not? And if not, what can we do about it? And if tomorrow we get 10 times the volume that we have today, can we just scale using hardware, or will it just not work? Because that's the big surprise that you can have. You may think that you can always add some hardware, but that doesn't always work.
Perfect. Thank you. Thank you for your time. Thank you for your presentation and also for your answers. It's now time for us to take another break and meet back here in 15 minutes. Don't forget to hydrate and check out the Digital Expo, where a lot of surprises await. Remember, each session is broadcasted independently, so make sure you check the live session tab when returning. Thank you.
Thank you. Bye.
Bye-bye.